Hey, welcome back. So we're going to go into the next type of formula writing. So far we have had ionic compounds and we've had molecular compounds. We hope you've had a chance to learn that, whether it's been from watching these videos or from working on Khan Academy or wherever you've been learning the information from. So today I'm going to talk about polyatomic compounds, which the cool part about these is it's just like doing ionic compounds. It looks a little bit more tricky, but it really is the same thing. So what is a polyatomic compound? Well, this is basically what happens. If I wanted you to write a formula involving, anything, let's say sodium oxide. So if I told you to write sodium oxide, we would go, okay, well, sodium we know has one valence electron, and oxygen has, if we drew dot structures, we would say oxygen has six valence electrons, and that's fine. And we would go, okay, well, this valence electron goes there, and then this valence electron from a second sodium would go there, and we'd end up with Na2O. Perfectly fine. So in this case, oxygen had this dot structure where it took on two electrons, and that's why this whole thing works. And we're used to that by now. So with a polyatomic compound, the similar thing kind of takes place, except we don't have oxygen. Instead, we have, well, a polyatomic. Poly means many, and atomic is talking about atoms. So we have more than one atom. Give me 1 second, I forgot my eraser. I'm going to erase this now, and I'm going to change this up just a little bit. So instead of having this oxygen, now what happens is, let's say we have a polyatomic compound, which happens to be, you can find a list of these on the back of your periodic table. On the back of your periodic table, we have all the polyatomic compounds. It'll say polyatomic anions and give you a big list of them here. There's actually one polyatomic cation, ammonium, which is over here. And this is just a big list of ions in general. So I'm going to look on the back of there, and I'm going to find, say, carbonate. Carbonate, what it'll say is it's going to say CO3, and it'll say 2 negative. Basically what that means is it acts like this is one big thing, and it kind of acts like, now nobody ever does this, we don't actually draw this like this, but it acts like it has a dot structure similar to oxygen. Now, I've never actually seen somebody draw dots like this around a polyatomic ion, but I'm just doing it because it makes sense. So if I wanted to write sodium carbonate, what I would do is I would still write my sodium, and it still has one valence electron, and this sodium will send an electron there, and we have another sodium like this, where it's going to send that electron there, just like as if this was oxygen. Because carbonate, when this whole thing forms, when the carbon and 3 oxygens form together, it actually leaves a space on 2 of the oxygens where it can still take on an electron. It's a little more complicated than this little dot structure like we had in oxygen, but we're not gonna deal with like how it all goes together and whatnot. Basically, we can think of it as it has a place for just 2 electrons to go, so it acts just like oxygen does. And we end up with it's kind of the same thing. So instead of Na2O like we had in the sodium oxide example, now we just have Na2, not Na2O, I was just talking about sodium oxide, and it's Na2, and then we just write the entire thing, CO3. So Na2, and then CO3. So we have sodium carbonate, and this whole thing, this whole CO3 is one big ion called carbonate. So that's all we really have to do. Now, you're not going to go through and draw your dots. You're not going to go through and draw these arrows, just like we didn't do that when we were doing our binary ionic compounds. So what we're going to do is we're just going to go through, and we'll be able to just go through and just, check, check our charges and balance charges and whatnot. So let me do another example. Let's say we have magnesium. You just can't spell. Magnesium nitrate. So magnesium nitrate. So if I look at this, magnesium, I can look on my periodic table, and you guys know how to do this already. You find magnesium, and we find out that magnesium is a 2 positive. So what I'm going to do is I'm going to write Mg, and I'm going to write 2 positive right here. And then I'm going to look on the back side of my periodic table, and when I look on the back of my periodic table, I can find nitrate, and it tells me that nitrate is NO3 1 negative. So I'm going to write nitrate NO3 1 negative. Now when I do this, what I'm going to do is I'm going to balance my charges just like I did with my binary ionic compounds. So in this case, if I look at my charges, this basically tells me that I have one magnesium and I have one NO3, but a 2 does not balance out a 1. So these don't balance right. So this can't be my formula. So what happens if I have a 2 and then I have a 1, I'm just going to take my another nitrate, which is also, this is a full ion. This is one big ion called a polyatomic ion. So this is my 1 negative. And now when I look at that, I have 2 positive and I have 2 negative. My charges balance. My charges are all balanced out now. So now I can write my formula. So I just go through and go, okay, well I needed 1 magnesium ion and I needed 2 nitrates. Now this is tricky. I can't write NO3 and then just write a 2 right here, because if I just write a 2 right there, it's going to look like NO32, and that doesn't work. So what we do is we write parentheses right here. So we have NO3, that's supposed to be a 3, it looks kind of funny. And then I have a 2. Mg NO3 2. Now, on one of the worksheets that I have up online, it asks you, when you get to this formula, how many ions do you have and how many atoms do you have? So when it's asking about the ions, we have 1 ion, 2 ions, 3 ions. We have 3 ions. We have 1 magnesium ion and we have 2 nitrate ions. But we also have, if we count the atoms, look how many atoms I have. I have a magnesium, I have 2 nitrogens, 1 from each of the nitrates, and I have a total of 6 oxygens. So if I wanted to count on my number of atoms, I have 6, 7, 8, 9 atoms. So one of the worksheets makes you count that. That becomes really important down the road. Be able to count these up, especially being able to count up the number of atoms you have. You should be able to look at a formula like this, and you're going to need to be able to count up the number of atoms. If I said, how many oxygen atoms do I have in magnesium nitrate? You need to recognize that and go, okay, well I have O3 twice, so that's 6 oxygens. Or I have nitrogen twice, I have 2 nitrogens. I have 1 magnesium. You've got to be able to count those up. So again, you're going to find your ions, and you're going to balance your charges just like we did with binary ionics. And then you're just going to write out your formula. And then when you need to count your ions, there we go. You just go, okay, well 3 ions, 3 charged particles, yet we have 9 atoms, because now I count up every single one for the number of atoms. Okay, I'm going to do one more example. So let me erase this. This time, I want to be able to write a name if I'm given a formula. So let's say I'm given something like this. This looks tricky. NH4 3 PO4. Okay. I know somebody who hasn't seen chemistry much lately might look at that and just be like, okay, how the heck am I going to name that? That looks crazy. But when you start understanding your ions and be able to recognize your ions a little bit better, this isn't very difficult, because all we have to do is now look up NH4. That's an ion. In fact, that's a polyatomic ion that you have on the back of the paper. So if I just have NH4 and I find this right here, this is called ammonium. And then this PO4, you just find PO4 through here, and you can figure out the charge actually, because there's a 3 right here. And if ammonium was a 1 positive, that implies that this must have been a 3 negative. And it makes sense because phosphate is PO4 3 negative. So this is just ammonium phosphate. And that's how you would name it. Now, one question that I've had a couple of times already is, what about these ones with Roman numerals? These can be a little bit crazy. And a couple of the worksheets, we had to do that already. So how do I know what Roman numeral to use? So if I have, like for instance, let's say I had, this isn't going to be polyatomic, but let's say I had this, SnO2. So that's SnO2. Well, we have to be able to figure out when we name this, we can't just name this tin oxide, because tin, if you look at your periodic table, it actually has 2 different charges. It's highlighted on your periodic table. So I need to be able to figure out that charge. So if I write this out, I have 1 tin and I have 2 O's. And I know O's are 2 negative, So if I draw this out like this, I can look at it and be able to tell, okay, 2 negative, 2 negative, that's a total of 4 negative. And if I only have one 10, then that tells me that this had to be 4 positive. So in that case, I know that when I name this, I'm going to write out tin, Roman numeral 4, oxide. So I was able to find the charge on that tin. And it works out. There we go. We're good. And we can figure out that. Remember, the Roman numeral tells me the charge on my cation. Never use a Roman numeral on an anion. There's no such thing. Okay, one more example, and then I'm going to call it a day. Okay, so what if we wanted to write a formula for, let's say, barium chlorate. So barium chlorate, we're going to look at this, and again, you just find barium, second group, okay? Well, that's going to be a 2 positive. Now this is how I do it. I don't always write it out. I'm going to write the charge right here. Now when I find chlorate, I go to the back side, and I see chlorate and go, okay, well, that's a 1 negative. So this is a 1 negative. I just look at that and go, okay, 2 positive, 1 negative. Those don't balance yet. So I'm going to write another 1 negative. Now that balances. So now I can look at this and go, okay, well, barium, okay, I only needed 1 of them because I only needed 2 positive, yet I needed 2 of these. So then I find chlorate right here. And one of the reasons I chose chlorate is because on the back of the periodic table, I see this every semester. I see kids who will write CiO3. That's an L right there. It's chlorate like chlorine, so ClO3. That's just a common thing that I see. So I wanted to do one with chlorine. So Cl like chlorine, and then O3. It's not an I, even though it looks like it on the periodic table. So BaClO3. And then, of course, I need parentheses, and I needed 2 of them, so I put the 2 down there. Okay, so it takes a little bit of practice. One of the biggest things is being able to identify what type of compound is formed. So formula writing, again, just takes a lot of practice. I put a ton of worksheets up there, a ton of practice. You need to do as much as you possibly can because formula writing does not go away. We're going to be doing formula writing for pretty much the rest of the course, and you have to get perfect at it. So practice, 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 just like anything else, and just, just learn how to do this as well as you possibly can. All right, until next time, I will talk to you soon. Take care.